Hey guys, so make sure you use this video to double check your answers before you guys submit. Don't forget that tomorrow is your Unit 7 test. This is why you're having a second study guide, but let's take a look at our answers. So for what should you have gotten for number one? So it says square B is a dilation of square A. What is the scale factor? So again, scale factor, might use SF for short, scale factor, not San Francisco. That's new over old. It's just a comparison between the new one and the old one. Well, you have to know which one's the new one, which one's the old one. So it says square B is a dilation. Okay, so that is the dilated image. So square B, the one that I see here on the inside, that is going to be the new one. That is going to be the new one. And of course, square A, the bigger one here on the outside, that is the old. So now that I know that which one's the new one, which one's the old one, we can go through and actually find our scale factor. Okay, so let's find a side on the new one. So the one in here, in the smaller one, square B, this right-hand side over here, I should pick a different color. This right-hand side, so it stands out a little bit more on the new one, that measures a distance of 30. Okay, so we're going to write scale factor is equal to 30 over, well, now I need to compare it to the same side on the old one. Here's the issue, right? If I take a look at the right-hand side, I'm like, well, what should it be? What should it be? Well, don't forget, this is a square, right? So the old one, if the top measures 35 of that square, top side of that square measures 35, so does the right. So we're going to compare it to 35. Okay, so what is our scale factor going to be? Well, our scale factor is 30 over 35, but we do want to simplify. I can actually divide top and bottom by 5. So my scale factor is equal to 30 divided by 5 is 6, 35 divided by 5 is 7. That is our scale factor. And again, 6 over 7 is a number between 0 and 1. If you give me the decimal, you get a decimal between 0 and 1. And it makes sense, right? Whenever we have a scale factor between 0 and 1, it shrinks it. So take a look at the old one. It was bigger, got shrunken down to the new one. All right, what about problem number 2? Very similarly, it's asking us, guys, what is the scale factor that was used? So scale factor, that is equal to the new over the old. All right, make sure we know which one's the new one, which one's the old one. How do I know in this case? I see a B prime and a B. So the one that has the prime, that needs to be the new one, right? A prime, B prime, D prime, and E prime. Which one is going to be the old one? Well, just your regular A, B, D, and E. So let me label this as the old one. Okay, so looking at just old to new, I see that the new one got bigger. My scale factor should be a number greater than 1. So let me figure out a side. Let me find a side to actually work with. I'm going to pick blue here. So pick a side on the new one. I'm going to pick this time, I'm going to pick the right-hand side. 1, 2, 3, 4, 5, 6, 7, 8. That measures 8 units. So my scale factor is going to be 8 over, let me compare that to the same side of the old one. From D prime to E prime, so from D to E, 1, 2, 3, 4. That is 4 units. Well, we can do better than 8 over 4. What's 8 divided by 4? That gives us 2. So our scale factor here is 2. And we can see that, hey, going from the old one to the new one, it doubled in size, right? Going from the old to the new, we can see it got bigger. It doubled. All the dimensions are doubling in size. Okay, problem number 3. Perform a dilation from the origin. And we're going to use on triangle OMG using a scale factor of 2. My scale factor is 2. I know this is going to get much bigger. And since we're dilating from the origin, from the center, we're going to go ahead and use the coordinates. We're going to use the coordinates for O, for M, and G. So what are the coordinates for O? That's -4 to the left, and then 1 up. So not 4, -4, and then 1 up. What about M? M, that's 3 to the right and 2 up. So that's going to be 3, 2. And then what about G? That's 2 to the right and -2 down. So 2 to the right, -2 down. Well, in order for me to dilate from the origin, we're going to use this coordinates. Now we actually have to apply our scale factor. Whenever you apply your scale factor, all that means is you're going through and you're multiplying your x and your y values by that scale factor. Okay, so what are my new coordinates going to be? Well, O prime is now going to turn into -4 times 2, -8. 1 times 2 is 2. What about M prime? That is 3 times 2, which is 6. 2 times 2 is 4. And then lastly, G prime. 2 times 2 is 4. 2 times -2 is -4. So these are the new coordinates of my image. That's going to help me with my dilation here when I come back and actually plot those points. So let me go -8 to the left for O prime and then 2 up. Label that before you forget. That is your O prime. What about M prime? 6 to the right and 4 up. Label that as your M prime. And then lastly, G prime, 4 to the right and -4 down. That is going to give us our new G prime. And you want to make sure you come back and connect it. And there we have it. That is our dilation. That is how you perform a dilation from the origin. Okay, take your coordinates, multiply them by your scale factor. Okay. Problem number 4, it says quadrilateral ABCD has the vertices with the coordinates below. So they give me the coordinates down here, ABCD, right? Imagine that was graphed. I took all those coordinates. If the quadrilateral is dilated by a scale factor of 1/3, remember when you multiply by something like 1/3, it is going to make it smaller, right? It's a reduction, and it's with the origin as the center of that dilation. So that's why I'm able to use the coordinates because we're dilating from the origin. If I was dilating from a specific point, I would not be able to use these coordinates. So what are the new coordinates of the image? Well, I have the old ones. Let's go through and apply a scale factor of 1/3. Remember, when we say apply, all that really means is you're multiplying everything, not by 1/2, by 1/3. Every x and y value here is getting scaled by a factor of 1/3. So we're multiplying every single thing in here by 1/3. Okay, so I'll show my work for this first one here. What is -3 times 1/3? Well, how do you multiply? How do you multiply a whole number times a fraction? That's -3 over 1. You multiply across the top. That's -3 times 1, which is -3. Across the bottom, 1 times 3 is 3. And then -3 divided by 3 gives you -1. Okay, so right there, we're going to end up with A prime, at least for the x value, that is going to be -1. The shortcut really is take your number, and whenever you multiply by like 1/3, 1/2, 1/4, 1/5, you're really just dividing by that denominator, right? -3 divided by 3 gave me -1. Okay, if I do that same thing with 0 over here, 0 times 1/2, well, that's going to be 0, right? That's kind of obvious. But let's try that one more time here with the next. What is that going to give us for B prime, the x coordinate for B prime? What is -12 times 1/3? You could go through if you wanted to, put -12 times 1/3, right, and work that out. But we know the shortcut, whenever you multiply something like 1/3, you're really just dividing by 3. So what's -12 divided by 3? That is -4. All right, I do the same thing over here with 15 divided by 3. Well, that's going to give me 5. Let me keep doing that with C prime. What is -9 divided by 3 times 1/3? That's the same thing as dividing by 3. We get -3. 6 times 1/3, or 6 divided by 3. A third of 6 is 2. 6 divided by 3 is 2. And then D prime. 3 times 1/3, or 3 divided by 3 is 1. And then -6 times 1/3, or -6 divided by 3 is -2. These are all your new coordinates. That's your A prime, your B prime, and your D prime. Okay, problem number 5 says dilate the triangle using a scale factor of 1/2. So I know this is going to shrink it. And this time, though, we're using C as a center. So C will not move. Okay, I can't use the coordinates this time. C is also going to be C prime. So this time we actually have to focus on the lengths. Well, what was the length from A to C? Well, that used to be 1. Well, find a color that stands out a little bit more. Yellow's kind of hiding. 1, 2, 3, 4, 5, 6, 7, 8. That used to be a length of 8. But when we apply our scale factor, what's 8 times 1/2? Well, put the 8 over 1, multiply across the top, we get 8. Multiply across the bottom, we get 2. 8 divided by 2 is 4. So that distance that used to be 8, it's now getting cut in half by a scale factor of 1 over 2. So instead of going from C to A, I would go up normally 1, 2, 3, 4, 5, 6, 7, 8 units to get there. Now we're only going to go up 4. We're only going to go up 4. Let me go back to red. 1, 2, 3, 4. That is where the new A prime is going to be. That is your new A prime. Okay, we're going to do the same thing. We're going to do the same thing with C to B. C to B used to be a length of 1, 2, 3, 4, 5, 6, 7, 8, 10, 11, 12. That used to be a length of 12. But when we apply our scale factor of 1 over 2, right, and I'll go ahead and I'll show my work for this one. Across the top, when you multiply, that's 12 times 1 is 12. 1 times 2 in the denominator is 2. 12 divided by 2 is 6. That distance that used to be 12, it's now getting cut in half by a scale factor of 1/2. So we're only going to go over 6. So from C to B, it used to be 12. We're only going to go over 1, 2, 3, 4, 5, 6. That is going to be your new B prime, right? And then C doesn't change. C is going to stay as C prime. We can go ahead and finish by connecting all 3 coordinates here, all 3 points. That is our new triangle here. That is our new triangle, right? And we can see that our scale factor was 1/2, so it got shrunk. You can see from the blue one to the red one, it did shrink, and it was shrinking towards our center here, which was C. C, think of it like a black hole. It was pulling everything towards C, or in this case, C prime. All right, problem number 6. There's more than one correct answer. So this one, it just kind of depends on you, how you defend it. It says use words like reflection, right? Reflection is when you are flipping over either the y-axis or you are also flipping over the x-axis. Okay, a dilation is what we've been talking about recently, right? When you take an image and you either enlarge it or reduce it, depending on what way you're going. And then the last thing here, translation. Remember, a translation is when you move something up, down, left, or right. So we're going to use these words to describe the following transformation. How did I go from A to A prime? Well, one thing that you could have said, how do you go from A to A prime? You could have said that they translate that arrow. So again, just shifting it over here. Obviously, this is not going to be perfect. Right, it's just describing it. That's a terrible, terrible arrow. Try that one more time. Right, you don't actually have to perform the arrow. I'm just trying to show you guys. So we can say, oh, okay, we translated the arrow to the right. And then we could have said after that, we reflected it over the x-axis. We flipped it down. So we ended up with this much larger arrow. And then the last thing that we have to do, so we were able to scoot it to the right by translating it. We were able to scoot it down by reflecting it over the x-axis. But how do I go from this big red arrow down to the smaller blue one? The last thing we could say is we dilated it in order to reduce it in size. Okay, so we dilated it to reduce it. It was a reduction, right? You can say you dilated by a scale factor between 0 and 1. Okay. Is that your only option? No. There's more than one correct answer. Some students prefer to go this way. Some students will say, okay, we reflected it over the x-axis first. And then we translated it to the right. And then the last thing you could have said now is dilated. So there's more than one correct way to arriving at our answer, just to give you guys an idea.